Yeah.
Great. So hi everyone. Welcome to the second day. I'm so happy to see you today. And during this session, we are going to cover how to make your server portable and easy to deploy. And our final goal of this session is to pack your service you built yesterday to the images and run it as containers. So everybody have Docker installed on your machines, right? So after a short presentation, we will start our workshop, and we should okay, let's start. So for new people, who am I? I'm Denis, and I'm a software engineer. Usually I do software architecture, system design, and coding using Golang and Kotlin programming languages. Right now I'm working at a fintech startup. We are making digital bank. So agenda, we will talk a little bit about history, what is Docker, images and containers, what is Docker files, how to run our containers, and how Docker Compose will help us to make things easier. Expectation we can skip. A little bit about history. Long time ago, people running their servers in traditional way. Just we had our operating system, and we just launch every application without any helpers, like just on this using this operation system without any separation. All libraries were at the same place, and things got a little bit messy. After this, virtualization comes, and we started to have hypervisor. So we started to launch different operating systems, and application launches separately on each operation systems. After this, Docker comes into the game, and it helps us to install Docker engine on our operating system, and Docker helps us to split application from each other using this Docker engine. So how it works? Docker engine can be launched on like any operating system very easily, and using containers, we just can launch our application using Docker, a platform, and we don't think about operating system stuff. We just launch our containers and they're working. What is image actually? Images are ready templates that contain the instruction needed to create our container. Later, we will see how it looks like. Container is a unit of software that packages code, all its dependencies, libraries, to run our application quickly, and allows to port our application from one environment to other. So this is the life cycle of how Docker builds and run applications. So we have Docker file. We are building Docker image using this Docker file. And after this, we can run container using this Docker image. So Docker images can be distributed using different remote repositories, like like GitHub, but GitHub is for code, but we have a Docker Hub, and this is like remote repository database for storing Docker images. You also can deploy your own image storage on your own remote server, for example, if you want. So this is how containers looks like when you run it. So Docker PS commands show running containers. So here we can see like container ID, image, and commands, what ports this container exposes, and the name. Docker images shows you the list of all available images right now on your computer. Docker file is a blueprint, and it's just a text document that contains all the commands user could call on command line to line to assemble your image. Here is a simple example of Docker file that helps us to make a container, and inside to make an image, and inside this image we are building just a small Python application. And here how we can build our image using build -t and the name of our image commands, and all instructions from this file will be executed step by step, and finally we will have our ready image that we can run as container. Running containers. Using Docker, it could look like this, but it is a lot of different commands and looks pretty hard. So that's why later we will talk about Docker Compose that helps us to pack all these commands into reusable config files. This is how we can manage containers. After we launch our containers, we can stop, remove, run them, check logs of these containers, and so on. Now let's talk a little bit about Docker Compose. As I mentioned previously, Docker run, we don't want to each time use all these long commands to run our containers. Also, when you need to add different networks and other settings, these commands, these Docker run commands could start to be really long and inconvenient to use. So we are using a Docker Compose file to pack all these things in one place in human readable way, like this. And Docker Compose, it is a tool for defining and running multi-container applications. So also you can describe what services you're going to run using Docker Compose, like this. And after running, Docker Compose will help you to, will build your image, for example, if you want, or download this image from the remote repository and run it as you described here. This is standard Compose file format. Here we're defining our application, building it from our current directory, exposing ports, and here is database service we are going to launch. We are using a Postgres image because we are using just image name It will download it from the remote repository, official Postgres repository. And using environment variables, we can customize our container without changing code. So usually using Docker Compose, these two commands enough. We are just Docker Compose up, and it will start all services you described in your config file. And Docker Compose down will stop and clean all stuff after you. Networking. So when you run your Docker images as a containers, they should to communicate somehow, and network will help us to do this. So usually we creating different networks using Docker network commands, or we can describe how to create network using Docker Compose file also. And this network, so your applications, your containers could connect to this network and communicate via this network inside Docker environment. So we have different containers. They have its own virtual interfaces. And after connecting to network, these services could communicate using service names, not IP for interactions. So it is really convenient. So we don't need to know IP address of each service, because it could be changed at any time. So we're just using the name of our service and the port. So and start communication. Environment variables in compose files, as I mentioned previously, it helps us to customize the behavior of your containers without changing any code. So you created an image, and you would like to, for example, it's a database image. Obviously, we have different variables like username, password, connection strings, and so on. And using these syntaxes, we can define environments, log level, and other things. And when container starts, your image will use these environment variables at runtime. So summary, Docker helps you to make your application portable, reusable, and helps to keep your operating system clean. So images ensure consistency, containers provide scalability, portability, and across different environments. So it doesn't matter where you run your images. If this system has a Docker engine, you can easily run your services on Mac, Linux, or Windows operating systems. So that's it. After this, we will start our workshop, and we'll pack our server into an image and run it as a container. So let's, if you have some questions, yeah.
I have a lot.
Okay.
So why did people decide to make Docker?
Why people decide to install Docker?
Why was Docker created?
Why? Docker was created because let's return stuff. First, Docker was created because people tired to manage all dependency things on the single operating system, for example, and decided to separate these environments. Because before Docker, if you are building your service, you should think about what operation system this service will be run at. And you will think about libraries. Does this environment has all needable libraries? Also, when you install all these libraries in the one single operating system, different application needs different versions of libraries, and these libraries can conflict in the same environment, and it is really hard to manage. So that's why people invented Docker to keep service and all its dependencies, all its libraries in a single place that won't affect whole operating system.
So follow up. So cool. But yesterday we learned about virtual environments.
Yeah.
And virtual environments basically do the same thing.
Mm-hmm.
So if we can do the same environment with a virtual environment, why do we need Docker?
Good question.
And if you need help, I can help you. I'll just let you.
I can suppose.
Grab a mic.
Yeah, virtual environments. Yeah, you can use virtual environments on your server also, but I guess it's more for development. And with virtual environments, the problem of operating system still exists. You still need to think about what operating system you're going to run your application. For Python, I guess it doesn't matter, because if a system has a Python engine, it couldn't run all Python application. But for example, for Golang, it makes sense like this.
Add to your answer?
Yeah.
So let's say you're doing some kind of image processing with Python, right? But that image processing requires a system library, not a Python library, but a system library, right? A Python virtual environment is not going to cover a system library for you, right? But a Docker image also includes a whole file system, basically a whole Linux installation, okay? So if there's some kind of system library you need or system level configuration you need, you can put that in a Docker container or in a Docker image using this Docker file. So you can say, run apt-get install Python 3, right, to make sure you have the right Python version, or install some image processing system level library, this kind of thing. Now, can you go back to your virtual machine slide? So in the olden days, back when I was a junior engineer, I'm old, we had these virtualization, right? Who here has used VirtualBox? Oh, wow, that's a lot of you. Also, it's not dead. That makes me happy. So who remembers downloading the Ubuntu virtual disk image? That took a while, right? Now, how big is that image? Does anyone remember? About? It's like a few gigs, right? So virtual machines, right? The idea was, so why is it called an image? I'm gonna give you a quick little history thing here. Who remembers CD-ROMs, right? It wasn't that long ago. So CD-ROM, we call optical media. Why optical? Optical has to do with like vision, yes, but it's really based on light. And when the CD-ROM is spinning, okay, there's a laser shooting at the CD-ROM, and then the CD-ROM, based on whichever point that laser is hitting, reflects back. And whatever the reflection is some kind of data bit. Okay? And that's how a CD works. And so because it's basically light going back and forth, we would call what's on a CD an image, because an image is just a reflection of light. Okay, so that's why we called it an image on a CD-ROM. Now, when you installed an operating system, you would have a CD with some image. You'd put that in the computer and install the operating system that way, right? When virtual machines came around, it was this idea of, hey, all this, defining your system, your file system, like installing your system libraries or various other configurations that you needed, like I talked about that, like maybe image processing library or something. Rather than install that on every computer every time, let's just have a pre-built operating system with everything already installed and all that. Let's just make it an image, and then we can just put it on some computer, and then we can have that computer run multiple operating systems on top of this hypervisor, like Dennis has shown here, right? And that way, we can run a bunch of different things using just one piece of hardware. So it's resource efficiency, and it's consistency, or it's environment consistency, right? Your file system is the same. The stuff you have installed is the same. Everything is the same, okay? So you don't have to worry about, oh, if we run on this computer or that computer, there's a problem, okay? The problem is, we talked about that Ubuntu virtual disk image, right? It's gigs, right? It's too big, okay? If you want to pass around images, or let's say on one server it goes down and you need to add this image to another server, and it's going to take minutes, that's hundreds of thousands of users you've lost in those minutes, right? So we needed something faster, we needed something lighter weight. Can you go to the next one, Dennis? So Docker Engine, you can run it on any operating system, asterisk. It's actually not true. From a user perspective, it is true. From a user perspective, it is true, okay? You install Docker Desktop or Rancher Desktop or whatever, and it works regardless of if you're running Mac, Windows, Linux, whatever. In reality, Docker only runs on Linux, period. What's happening is, if you're on a Mac and install a Linux virtual machine, and if you're on Windows, you're using WSL, which is kind of a virtual machine, kind of not. WSL is weird, but in any case, you have Linux on your computer, whether you knew it or not. Okay? So what happens is, a virtual machine emulates an entire operating system, end to end. Okay, but a Docker image uses Linux as the baseline and just creates a virtual file system within that actual Linux operating system, right? And therefore, you don't need the whole Linux operating system in your Docker image, right? You just have a mini file system. And that mini file system makes it much smaller. There are Docker images that are like, I think, double-digit megabytes, right? They're tiny. Okay? And that makes it much easier to pass Docker images around, right? So when you do your Docker Compose with Postgres image, it takes just a few seconds to download. Well, at least on Korea's internet, because Korea's internet is awesome. But that is why we as in like humanity, created Docker to basically provide the advantages of virtual machines while still being faster, lighter weight, and easier to work with. Because with a Docker image, you can define, can you go to Docker file again? You can define it using a Docker file, right, like this, right? But to set up a virtual machine image, you have to install the operating system, configure it exactly the way you want, and then you basically just have to take a backup of the operating system, right? So it's a lot of manual effort. Whereas with Docker, you just write some text and you're done. You have a Docker image, right? So it's a much easier to use from a user experience in terms of creating images, and the images are much smaller and easier to pass around. So that's the biggest advantage over virtual machines. And as Dennis said earlier, the main thing is these are portable, right? You can set up Docker on any system through Linux, basically. And then it doesn't matter what you have installed on your local computer, because it's only within the Docker image is what matters. Additionally, can you go back to the networking one? You can run a bunch of Docker containers on a single operating system, okay? Now you can do that with virtual machines too. However, with a virtual machine, you have an entire operating system that you're emulating, right? That's a lot of overhead, right? You have a whole kernel, or maybe dozens of kernels if you're running dozens of virtual machines. But with Docker, you can have dozens of images, but you're not running a whole operating system with each container. It's just a tiny file system, and you're just using up a little bit of CPU, okay? So that's another advantage, is Docker containers are also more lightweight than virtual images, or virtual machines. But the problem is, similar to virtual machines, each container gets its own IP address. But here's the weird part, right? It's not an IP address on like your Wi-Fi network. It's an IP address inside your computer. Your computer, when you create a Docker container, or rather when you create a Docker network, you create a virtual network in your computer. It's like your own mini internet. And so all the problems with networking that are true of the real internet are now true inside your computer. So that's why all this stuff is important, okay? Now, normally, you don't need to think about this too much, okay? If you write everything in the same Docker Compose file, it's all in the same network, you're okay. If you have multiple Docker Compose files, then you have to worry about the network interaction, but it's very rare that you'll do that. In the case of Kubernetes, that's a whole other mess that we're going to cover in day 5, but that also handles a lot of this stuff for you, okay? So, sorry for jumping in, Dennis. I just felt there was some context that needed adding.
So we can continue and go to a workshop, right?
Well, before that, any questions?
Yeah. Questions.
Can we only run a web service on Docker or other Android or mobile apps, or only it's tend to be used with web servers?
Very strange.
Usually Docker uses for backend applications, because for Android or iOS, you don't need such things. You just run your application on your operating system. It's iOS or Android. That's it.
Yeah, so there's no constraint about what you can run in the container, but I don't think it makes sense to run, I don't know, does it? I don't. So if you're talking about running a container on a mobile device, that doesn't really make sense because each app has its own sandbox. So, but if you're talking about running mobile devices virtualized via Docker, I don't know. Do you know?
I haven't tried it before.
I mean, theoretically, it should be possible.
Theoretically, yeah, you can just.
I think you need Xcode.
Yeah.
I think you need Xcode for everything.
Yeah. So you need Xcode common like tools to build and run your iOS applications or macOS applications.
Thank you. This might be a new question, and I'm sorry for that, but you previously told that Docker is a local container, right? Or
No, Docker is not container. Docker is just the system for managing containers. Yeah.
I see. And what's the difference between the Docker container and, for example, any online database, for example, I don't know, let's say Superbase. So we can store our images there as well and fetch them from Supabase to our, I don't know, code. Then what's the difference between Supabase and the Docker container? As I understood correctly,
Yeah.
we can store only images in Docker containers. Is that correct?
No, we are not storing images inside Docker container. Docker container, it is running version like of image. Like image is just environment with all libraries, with all dependencies, with operating system inside, and container. It's you run your image, and this image starts to be a container like this.
I'm sorry, I didn't get it. Then why do we need to use this container? Can we just use the image itself without any container and, I don't know, use the link for the image?
You need to run your image, and you need Docker engine for this, but it's just a format, like a standard to run your images. So actually, you can use, for example, not Docker desktop. You can use Kalima or other Docker like or other systems to run your images. So not only Docker.
So actually, I'm not expert about Supabase and all this stuff, but as you say, if Supabase has some kind of ready like image itself already, maybe like as a practitioner, it's okay if you just pull from Supabase directly, if that's the only thing you need. But if you need some more complicated systems, which needs like little different versions of Supabase or Supabase with something else, and with Docker, you can use Docker as like beneath platform to connect all things together, one to another, like in a minimalistic and easier way, like rather than you do it like just installing everything from scratch, every program. Any other questions?
Yeah, I have one question. Like, it sounds like Docker is like something like still better than the virtual machine, but from the business perspective, when you use virtual machine and when you use Docker, so is there anything like a virtual machine? Oh, okay. So yeah, so when you use virtual machine and when you use Docker, is there anything like a virtual machine can do but Docker cannot?
Usually, it depends on your organization and the company you're working in. But so if company have resources to launch, for example, Kubernetes cluster, and like you're using Docker, but just Docker images. So you're not using Docker engine to run your services for production. You're just using Docker images and run it as containers using other container management system. So if you don't have enough resources, I guess you can use virtual machines, and if you're not familiar with Kubernetes, like this. Companies I worked at usually using virtual machines when they didn't have enough money and people to manage more than things. So usually it is Kubernetes cluster with images inside like this.
What was the question?
The question was like, when people prefer to use virtual machines fully or Docker, is there any specific use cases when one can be more preferred than other?
And so the main use case is when you need a not Linux operating system. It's when you need a not Linux operating system. So if you need Windows, you can't use Docker, right? Or if you need Mac OS, you can't use Docker. Also, to manage Docker containers, you need access to the root operating system, right? And usually, oh, this is something we didn't cover. This is important. Ideally, a Docker container, is only running one process. Okay, so it's running your Python server, and that's it. There's nothing else. There's no other process running. I have to fix the audio. And then, if that is the case, then how do you access the container? You kind of can't, right? Because there's no other process running inside the container to receive your connection, right? So if you need to be able to directly manage the environment that your software is running in, you want a full operating system, but you can have many things installed on many services running, right? So if you need to be able to SSH into the Docker environment, maybe you want a virtual machine. This is why if you look at cloud services, right, like AWS, GCP, Azure, right? When you create an EC2 instance on AWS, basically it's a virtual machine, right? And that's because you as a user need to be able to log into the machine and do stuff on that machine, right? They can't use Docker for that. Because if they use Docker for that, you would be using the only process they could run would be SSH. But then if you try to run something in that shell, and then you terminate the connection, whatever you ran is gone, right? So you need a full operating system to do that. Does that make sense?
Yeah, that makes sense.
I'm very new to Docker, so this question might be too simple. But I was wondering in the part where Docker network is networking part. And while we are using different containers, how we will be reaching to each container? Is it through the network? And if it's network, how we can route every network here? Like each address of each container.
Well, each container can communicate using, for example, we created 2 networks for front end side and like backend sides. And like this application can interact with these applications using these networks. That's it. And they will use like Redis one service name to connect to Redis, or worker one to connect to worker, and so on. Like this. Is it answered to your question?
I didn't entirely understand your question. Can you try asking it again?
I was thinking that each container is different application, let's say. Is it correct?
Yes.
Okay. And for example, if we are using different containers, multiple containers, how we will be working on each container? Is it just the network? And if it is, how it will be reaching to it?
What do you mean by working on? You said if we are working on each container. What do you mean by working on?
If I'm checking each container, like if it's working or not.
So it's up to you. Okay. So can you go back to your Docker commands earlier? Where was it? No, there was something after that. Where was it? Oh yeah, there we go. Docker. Perfect. Docker PS shows you what containers are currently running. Okay, so it shows you what the state of the containers are. So you can see that there's this container with this name, infallible Roman, I guess. And then it shows you what image it's running. Sometimes if it's a named image, it'll have a name there instead of like that random hash. And then it tells you like, you know, what ports it's listening on, this kind of stuff. Is that the kind of thing you're asking about? Or... So Docker PS is how you can see the current state of containers.
And you can use different commands like Docker, I guess, Docker init and some options to enter to your running container and check what's going on inside. Or using Docker log command, you can check what's going on with your service inside your container, like this.
Does that answer your question? Other questions?
So on the Mac, it is technically slower, right? Because it's running over at, yeah.
So that's going to be, so the question for the purpose of the stream, the question was, so on a Mac, it's going to run slower because it's running in a VM. Technically, yes, but that's also true on Windows. But usually, like, if you're doing it on a Mac, you're doing it only for development anyway. So, like, performance isn't as big of an issue.
And I need to be careful with the CPU architecture and so on. Like, things I running or okay.
So the question was, do I need to be careful with CPU architecture like ARM or AMD 64 or whatever? Good question. I don't think so. I say that because I'm using an M3 and I have not noticed any issues. It just works. So I think it's okay, but
sometimes when you're downloading images from the remote repository and try to run it on the different architecture of Mac, you could see a warning that something can go wrong, but actually it works. Like only this difference.
other questions? All right, hands on time.
Yeah.
Okay. On time.
So yeah, let's start our workshop to pack your servers into Docker image and run it as container. You already have your servers and all your codes. Please open it and we will start from the basic ones. If you pulled like the project from our repository, you should have this Docker file inside it. Please raise the hands who doesn't have a Docker file.
So on their project, no one can have.
Okay.
And I think it's best to just have them start writing it from scratch anyway.
From scratch. Okay. So let's. You have such a project structure, and please create a Docker file in the root of this project, like this. Okay. Like just Docker file here.
Yeah, that EMB stuff, folks, I'm just gonna put that in the Discord.
Yeah, I guess we can just copy paste this Docker file.
Well, let's look. I think we should walk through each command to explain what it is and why.
Here we are pulling. Like here we are using our base image with Python with all Python stuff. Like we are using Python 3 and 12, and inside this image there is an operating system and all related to Python.
It's a base image.
Base image it's like a precompiled image with all needed tools. For example, for this, it's precompiled image with all tools for Python. So it is Python interpreter installed in this image, also basic Linux system, and you are going to extend your future image using this base image. You can think about it like class extension, something like that. You're using your base image and add like comments units to this base image to run your custom image like this. Here we're defining environment variables to configure Python in Docker environment. Here we are saying workdir. It's a working directory where we are going to put our source code and where we are going to run on all future commands. So here we are copying all source code from our local machine directory to inside the container. And starting to install all dependencies inside container. And after this, we can run our image. So when we like executing Docker run, this command proceeds, and your container could start. Yeah.
We can talk about Docker ignore. Oops.
Docker ignore. Yeah. By the way, I haven't used Docker ignore.
Okay, let's go back to the Docker file and let them get that going, and then we'll worry about the Docker.
Yeah.
All right, so everyone, scroll down the second part. Everyone take a moment to make sure you have this in your own Docker file. Okay, it should be in the root of your project folder. Okay, what's up?
Yesterday we used run as a command to run our project. In the last line, is it using app command? So if you change to run or you use app, will it run?
So this works. We tested this. If you just use run from the PyProject.com, it might work. I don't know. We try it.
What's command? I can and app does.
Also, it should probably be doing this.
So, for the benefit of the stream, the question was, this command and app thing, what is that? So CMD, that's a Docker file directive saying that when this container starts, what is the process that should be the one process running the container? And in this case, it's running Python. The -m is which module to run, okay? So in this, you know what a Python module is. And then the app module, if you, can you expand source app in your directory tree there? So you see that underscore, underscore main, underscore, underscore, right? Yeah, so we, this file allows you to basically run this module as its own script. You don't have to do it this way. What you could instead do is you could just do Python and then source app main, right? But the way that we built this Docker image, we tried to make it as small as possible without using outline. And if you add this underscore, underscore main, underscore, underscore dot py, okay, that allows you to run your app module as a script. So then you can just do Python -m app, and it'll try to run the app module as a script using this file. Does that answer your question? Cool. Now we expect you to run into a lot of issues, but has everyone got this written down here? Yeah. Yeah. All right, does anyone need help? We do have people available and ready to help, so.
So I saw the previous presentation. In the top, there's a form of Python worker. You can also set up the operating system.
So the question was, you can scroll back down so people can copy the rest. And then
scroll
you can
down.
scroll back down so people can copy the rest. Yeah, there you go.
Mhm.
So the question was, in our from directive, we say Python and then give it :3.12. But how do we specify the operating system? So usually the people who create an image, they specify which Linux version through the tag, right? So if you go to Docker Hub and you search for the Python image, you'll find that there's like Alpine 3.12 or Buster 3.12 or Slim 3.12. These are basically different operating system versions with that version of Python. So most of the time on Docker Hub, the maintainer of the image will include different versions of the image for different operating systems. Does that make sense?
Yeah.
For the Python image, I believe the default is some kind of Debian version. I think the latest Debian version. But you'll have to check. Does that answer your question?
Yeah.
Cool. Other questions?
Why do you remove the file project common and source file just to make
Ah.
it cleaner?
Yeah. So the question was, why do we remove PyProject tunnel and source? That's just to make things cleaner. Yes. Now you'll notice we didn't remove a bunch of other stuff. We're gonna get to that in a minute. Okay.
Wait, what? If you remove the source, then how does it run?
That's the good question. So the question was, if you remove source, then how does it run? Magic that I'm going to explain in a minute. But that's exactly the question I was hoping someone would ask. Good catch. But we'll cover that in a minute. And yeah, has everyone got this copied down now? Or are you still working on it? It's like a couple of people are still working on it. So while we're waiting for people to type this down, I'll explain another file. So if you look in the directory tree on the left here, there's a .docker ignore. Okay, don't click it because I want people to be able to keep copying stuff down. The .docker ignore. Who remembers what a .git ignore is? Okay, who wants to explain it?
Git ignore file, we say to Git what files are excluded from Git, and Git doesn't care about these files and ignore.
Perfect. Then what do you think .docker ignore does? If you have a guess.
I think the same.
That's exactly right. So you can create in your project a .docker ignore file, and Docker will just completely ignore anything in there, right? So you'll notice that he has this copy ./ which is the whole current directory, into the Docker image in the code directory, okay? But that should copy everything. However, because we have our Docker ignore, it's going to ignore everything that's in that .docker ignore file. All right, are we good on copying down this Docker file? Okay, I'm not seeing any protests. So let's go to the .docker ignore. Okay, so, we don't need our Git tree in the Docker image, right? We don't need our virtual environment in the Docker image. We don't need this Docker ignore file in the Docker image, right? So we list out all the files that we don't need in the Docker image, okay? And I'm gonna copy and paste this in a second in the Discord. You can just there's not a whole lot of intelligence behind this. You can just copy and paste it into the thing. But basically, by doing this, you can just save yourself a bunch of effort. And that's why we're able to just copy the entire directory and ignores all this stuff that we don't care about. And so between this and between removing the PyProject.toml and the source file, there's pretty much nothing left of our original files in the installed Docker image, right? real quick, Dennis, can you, on your terminal,
Mhm.
can you do a pip install? I'm sorry, pip install dot. So you'll notice here, it created that build folder. Okay. Dennis, can you look at that build folder? No, no,
Oh.
up. Okay.
Mhm.
So that build folder, okay, and lib, I guess. Yeah, there you go. This is why we remove the source. Because what happens is, when we do this pip install, it kind of builds our application, including all the dependencies, and puts them in this build folder. Okay, and then it's basically part of the system. And we can just run our Python module as part of the system modules. Okay, so that's why we can remove the source files, to answer your question. So let's go ahead and here, let me paste this stuff into Docker ignore. Everyone can paste that in the file. Sorry guys, multitasking here. Okay, so I just shared it in Discord. You can just copy and paste that whole Docker ignore file into a file in your project called .docker ignore. Okay, and now you can do this command here. Okay,
Yep.
Docker build takes a Docker file and creates a Docker image from that Docker file. We're almost out of time. The dot tells it, do your work in this folder. Okay, the -t gives it a tag. A tag is basically a name. Okay, so using the current directory, the Docker file in the current directory, the Docker ignore in the current directory, and the whole files in the current directory, build a Docker image and tag it, give it a name of Seollal Bootcamp. So you can go ahead and run that now on your machine. And what it's going to do is it's going to download the Docker or the Python Docker image. And then it's going to run all those commands in your Docker file, including installing your dependencies. And then we're good. So now, if you do, whoa, you're putting up your images now.
Yeah.
If you do Docker images, you can see this new Seollal Bootcamp.
1 gigabyte.
Okay.
Oh my god.
So do Docker build dot -t and then whatever name you want to give it. Okay. Now this is where you're going to start running into errors. So start flailing around and we'll come help you. All right. Has everyone got their image to build?
Yeah.
Okay.
Can you help? Oh, sorry.
I'm going to try to fix these microphones. All right. Everyone else's images has been built. Is anyone running into issues? You have an issue?
Others who who already has ready image can try to run it using this command.
we
Oh,
we didn't set up the Docker Compose yet.
no, we have Docker Compose, but first I would like to
Yeah.
use these commands, and after this, we will use Docker Compose file. It's here, ready. So maybe it's just easier to copy paste.
Yeah. Yeah, the problem is, your container already exists.
Okay.
And I'm just gonna copy and paste the. Actually, no, we don't need to do the Docker Compose yet. We're gonna do that in the setting up your database one. We don't need to worry about Docker Compose.
Okay.
So I would say just run it normally. Just run it with publish.
Oh.
Yeah. So yeah, get rid of the network. Just publish.
Can we get all the source project? Can we get it from GitHub?
Yes, but we're not to the point where we're going to use the whole thing. We're trying to build up to it.
But some people need a student, they don't have like project built on.
That one.
Yeah.
They can. Okay, we don't have enough time to completely catch them up. They're just going to have to catch up when we do the setting up your server one or setting up the database. I'll create a version of the repository where they can use that. All right. Yeah.
Yeah, if you have problems with network and your network not found, so you can create it like this, I guess, using this command. And after, everything should work well. If you have problems, raise the hands. I will help you. Sorry? To run this?
Yeah.
I didn't get.
You want us to run those commands after the Docker build?
Yeah. If you have a Docker image ready, you need to run this command. And if you have problems with network, you should create it using this command.
We Docker Compose. There was one on command above that.
Yeah, Docker Compose will help us to avoid all these commands. Like we will pack it's in separate config file and just use Docker Compose up, and Docker Compose will run all by itself.
So do the compose command first.
For Docker Compose commands, we need to set up our compose file. We will do it later, like in database section. Yeah, we don't need this command right now.
Right now, they just need to run Docker run.
Yeah.
Seollal Bootcamp, and then publish the ports.
Yeah. Also, we need to create network because
you don't need to create the network.
Yeah, we need because it does not exist.
It doesn't matter because all we're doing is publishing the port. You only need the network
we
if
need
we're
to
doing compose.
Yeah, here we need to remove or just create network because
You don't need a network at all.
But yeah, I got an error.
Really?
That's network not exist.
Right, because you tried to specify the network. What I'm saying is don't use a network on your run.
Yeah.
Yeah. Okay, sorry.
We need to remove this or just
And
create.
remove EMB. And remove. Actually, that's it.
Yeah.
So this, what they have now, if they run that, they're good. Okay, so is everyone able to, for everyone who was able to build their image, again, sorry for people who weren't here on day one. We didn't set up some stuff for you, but we're gonna fix it in a later session.
Mhm.
Can everyone run this after building their image? Except change, it shouldn't be 8080, it should be 8000.
80, 5,000?
8000. Yeah, I'm pretty sure. Let me double check, but I'm pretty sure.
Anyway, we can rerun our container with other options.
All right, so is everyone able to run that? Oh. All right. And then if you run this with the project that we set up yesterday, if you visit your browser on port 8000, you should be able to see your server. But this time it's running in Docker.
I hope.
Good? All right. Yeah. Sure.
Was this on the GitHub?
Hmm?
It's not on GitHub.
Yeah.
Can you share the link on Discord, please?
Okay. I can show like your code
Oh, yeah.
for backend.
Because there's some people that they miss it.
Okay.
They cannot.
So they can scan here, and I will send it to Discord. To the general, or where I should send? Here to the general, right? Okay.
So guys, if you're missing any part of the code script, so you can just clone it from the GitHub and run it right now. So that let's check it what you have missed it before. Yeah.
Also, I sent link to Discord.
All right, bear in mind that link is a more completed version of the project after we've done everything that you're going to cover today. So if you copy that version, you're going to see a bunch of stuff that you're not going to be like.
Mm,
All right, so does anyone else need help running their stuff, or is everyone? Yeah, I got you.
okay. Mm, Raise hand if you have questions. Yeah.
Yeah, you can make it whatever you want. But, oh, actually, wait a second. Oh, why? I should have prepared stuff better. Okay. So if you're trying to run this locally, then I'm going to change some stuff. So what you should be doing here, if you're using the code that you wrote yesterday, okay, the ports should be 8,000, 8,000. Okay. What that's saying is this is the port on your computer. Okay. And then this is the port in the container. Okay. So if you're using the code that we wrote yesterday, your server in the code yesterday should be running on, I think 8,000 is what we set. In any case, check your settings. We set up that Pydantic settings thing. Whatever port you have set there should be this number. And then this is the port that you're going to use on your computer, on your host machine when you try to access it in the browser. Okay.
Anyone else need help? Yeah.
Great.
Yeah, you send for please. Oh. I didn't see that. It doesn't matter if you just. So we started. Yeah, so it's exposed to something. Yeah. If you want. Remember it's yeah, let's the servers.
I need to do my yeah. That's just wrong. Yeah, here. Sure. So. Oh.
Oh, wow. Yeah. All right. Anyone else need help or are we good? Oh, now he's gonna kill me. Yeah. I think you can go it. Yeah. Yeah. Let me just do this.
All right, folks. So for those online, sorry that we've just been running around troubleshooting. We're basically done with this part. We're gonna share in the later session setting up your database in more complete working version. So if you're following online and your stuff's broken right now, we're gonna ask for your patience. Alternatively, you can ask on Discord. But we're gonna go ahead and end this live stream, and we'll get you caught up and fixed up in the setting up your database session. So thank you.
All right,